Okay, you made it. Chapter 10, Chapter 4, homework problem 10. Here we are to the final. A soil sample has a void ratio of 1.38, specific gravity of 2.80, and a water content of 32%. Volume of the solids for the sample is 1 cubic foot. We're going to complete a phase diagram, and we're going to solve for the degree of saturation. So let's do it. I put my default values in to start with. And then I'm going to go ahead and put in what else was given here. It told me that it was a 1 cubic foot volume of the solids this time, not total volume. So volume of the solids is 1 cubic foot. So I'm going to put that in here. Volume of solids is 1 cubic foot, not total volume. And I'm going to duplicate that for number 5. Write that one more time. Make our chart nice and neat. Okay, now I'm going to see what else I was given here. That's really the only information that I can write straight from my problem into my phase diagram. But I am given that specific gravity was given to me as 2.8. And I sort of remember that relationship of specific gravity is that it's the gamma of the solids over the gamma of water, which is a nice relationship because I always know that gamma water. So if I do a little multiplication here, I multiply each side by gamma water, I wind up with that specific gravity times gamma water is going to equal to the gamma of the solids. So it's really just multiplying that gamma water times this specific gravity rate, 62.4 ratio pounds per cubic foot is going to be my solid unit weight, and I'll go ahead and put that into my calculator. 62.4 times 280, and I'll get that times 62.4. 174, and I just want it to one decimal place, so 174.7. 174.7, and my units are going to be the same here because I'm just multiplying it by that ratio, that dimensionless ratio. And so I'll put that in for my number 6. It's 174.7. And when I take a look at this, I can see, look, I'm completing a row here because I know volume and I know a gamma. So let's just go ahead and find that weight of the solids. I know volume of solids times gamma solids is going to be weight of solids. And in this case, I have 1 cubic foot for the volume. I have 174.7 pounds per cubic feet for the unit weight, and that's going to equal my weight of the solids. And we can do that math very easily. 174.7, cross off our units, and we wind up with pounds. So I'll put that in for number 7. 174.7. All right, so we've gotten pretty far just from what was given and our specific gravity. So now we're going to go ahead and use that information about the water content. So I'm going to use that for my next one. You certainly, like I said, you can do these steps in a different order, but this is kind of what's coming to me as I do it, and the water content was given to us as 32%. I'm going to go ahead and write that as a decimal. And then I'm going to go ahead and look at my table and remember that relationship for water content. And there's a couple different values you could have used here but I'm just going to use this basic one. And since I just found that weight of the solids, I'm going to go ahead and use that information to find the weight of the water. So I'll slide this down here and write that relationship down. So the relationship I'm going to use is that it's the weight of the water over the weight of the solids. And if you think about it, that makes sense because that's actually water content, right? How much water is in it. And I'm solving for weight of the water, so I'm going to multiply both sides by the weight of the solids to get those to cancel out. And I'll wind up with the weight of the water is equal to the weight of the solids times the water content. In this case, my weight of the solids is 174.7 pounds. And weight of the water content in a decimal form, and that's going to equal my weight of the water. So let's go ahead and do that. 174.7 times 0.32, so 32% of those solids are going to be water, and so that's equal to 55.9 for my weight of the water. So I'll put that here, 55.9, and that's just in pounds because that water content doesn't have any units. And I'm going to put that over here, that's number 8, is 55.9. And I notice I'm always looking at these rows, seeing if I can add up. And I can here because I've got all my information here for my total weight. Let's slide that down and do that for number 9. So my total weight is going to be WA plus WW plus WS. And in this case, it's just 55.9 pounds plus 174.7 pounds. So we'll add those up here. 55.9 plus 174.7, and I get 230.6 pounds for my total weight. So I'll put that in here, 230.6. Okay, so I've gotten this far, but that looks like that's about all. Oh, I guess I could find my volume of water. Let's go ahead and do that because I can use that information across. Remember, I can't use this volume of air unless I know that it's 100% saturated, and actually we're solving for the degree of saturation, so we don't know what that is. So I'm going to go ahead and solve for this volume of water and see if I can figure out what that is and if that can help me. So let's slide this on over. And we'll solve for that volume of water. And that so we've got the volume of water times gamma of water is going to equal weight of water. In this case, I'm looking for volume of water, so I need to divide both sides by gamma water. Those will go away, so my volume of water is going to be my weight of water divided by gamma water. And in this case, my values are 55.9 pounds divided by 62.4 pounds per cubic foot. So let's go ahead and put that in the calculator, 55.9 divided by 62.4, and I get a nice long decimal. Remember, I just want to take it to the hundredths place, so I have a 5 next door. That's going to mean that has to round up, and if it's a 9, that's going to have to round up. So my value is going to be 0.9 cubic feet with my rounding. The pounds cancel out, cubic feet in the denominator of the denominator, and so that is number 10, is 0.9. Okay, that's probably all I'm going to be able to do without using some more information from my chart. So I'm going to look from my original problem. So one thing that I haven't used yet is the void ratio. So let's use that for number 11. My void ratio is equal to 1.38. Okay, when I look back, remember, if you can remember what it's the volume of the voids relative to the volume of the solids. Okay, so let's write that definition down here. E is equal to volume of the voids over volume of the solids. In this case, I don't know the volume of the voids, but I do know the volume of the solids. So I'm going to be solving for this volume of the voids. So I'm going to be multiplying both sides by the volume of the solids. So my volume of the voids, volumes of the solids will cancel out then. It's going to be volume of the solids times that void ratio. And if you think about it, again, that void ratio is how much of those solids. So let's do 1 times, I'm sorry, the volume of the solids, 1 cubic foot times 1.38, and that's going to be the volume of the voids, and so that's pretty easy. It's just 1.38 cubic feet is my volume of the voids. So I'll go ahead and put that in here for number 11, 1.38. Oh, now I can see I've got a column ready to go here for my total volume, and just add that straight down for number 12. So for number 12, I'm just going to add straight down and say the volume of the voids plus the volume of the solids equals the total volume. So it's just 1.38 plus 1. I'll make that number 12, and that's 2.38. So the total volume is 2.38 cubic feet. And I'll go ahead and duplicate that for 13, 2.38. We'll duplicate the volume, total volume. All right, now I've got some information here, so I'm going to be able to find out this. I could do gamma next or volume air. It's really up to you. I'm going to go ahead and do the gamma for 14 because I know volume, total volume times unit weight volume is equal to total weight. And so here I want to solve for gamma. So let me slide that down. So I'm going to divide both sides by the volume to get that answer for my gamma there. Let's slide that over a little bit. Let's put it next to it. Okay, so it's 230.6 pounds divided by 2.38 cubic feet. I'll put that in here, see what we get. 230.6 divided by 2.38. And you get this nice long 96 point, but remember just one decimal place for unit weight there, so 96.9 will work for us. Just stick it in here, 96, I think I have enough space, yeah. 0.9, and it's pounds per cubic foot. And that's going to be my 14. And then just to find my last thing that's missing here, my volume of air. I know it's always tempting to want to multiply across, but we don't know if this has 100% saturation. And actually, I can see here that it doesn't because my volume of the voids is not equal to my volume of water. So I'm going to have some volume of air here. That's going to be true. So there's a couple ways you could solve for that volume of air. You could try to add these up and see what you get, or you can just say volume of air plus volume of water equals volume of voids. You should get the same thing. I'm just going to go ahead and do it that way. So volume of voids equals volume of air plus volume of water. And so I'm just going to take that 1.38 feet cubed and subtract the 0.9 cubic feet. And that's going to give me my volume of voids. I'm sorry, volume of air. All right, so 1.38 minus 0.9, and that's 0.48. Let's put it up here, running out of space here for my volume of air. And that will be my number 15. And if I wanted to check that, I could just add it up down the column there. I've got the 0.48 plus 0.9 plus 1. Yep, 2.38. And I could also check across my rows here with the exception of the first row. And I can't check going down this column. So those are the two exceptions. All right, I'm almost done, but remember I want to look back to my initial problem statement and make sure I've solved everything. And there's one more thing. I need to know the degree of saturation. So we'll put that at the bottom here. And if you remember from your phase relationships, the saturation degree is equal to the volume of the water over the volume of the voids. And we're going to express that as a percent. So we'll just put that here. SR equals V W over VV, and in that case my values are 0.9 cubic feet over 1.38 cubic feet. So I'll go ahead and put that in my calculator, 0.9 divided by 1.38, and I'm going to express it as a percent, so I'll just multiply it by 100, and I'm going to use a whole number, so I'm just going to call that 65%. So not fully saturated, but more than halfway saturated. Okay, and that is the solution to Chapter 4, homework problem number 10. And that is the last homework problem from this set of the Chapter 4 homework problems.